Hello. So today we're going to be looking at surface raceways. It's basically just it's a raceway fill calculation, similar to how we did conduit fill. Yeah, just with a couple of little different ways of doing business. So here, when we look at the handout, it says convert metric units to inches for the raceways. Use the standard column for bare copper conductors. That's in table T5. And all installations meet the requirement of 10.612 subrule 3, which gives us some regulation on the use of bare conductors used as bonds. So when we look at this here, we're looking at a surface raceway as an example here. So what is the minimum size surface raceway for? And we can see when we look at the commercial wiring book, in the unit for alternate systems, it makes reference to these types of raceways. So when we look at a surface raceway, what is the minimum size surface raceway for 75 number 10 TW75 stranded copper conductors? So you want to be aware of what's going on here. Stranded solid is a bit of a change between them there. So we have here, we're looking at 12, 9, 10, subrule 4D, 10A, and again, very similar to what we're accustomed to with conduit fill. So the number 10's 15.67, there's 75 of them. We have a total area in millimeters squared. So here, what we're going to do is we're going to apply the code to the surface raceway itself when it comes into the 40% fill. So 12-1606 subrule 2, because 12-1600 deals with surface raceways. 40% fill. So what we're doing here is we're going a little bit backwards to actually track down the size of the raceway itself, the size of the, so this is the number that's total fill, but you can only fill, this represents 40%. So we can only fill it to 40%. So we take this, we divide it by 0.4. So the total area of the conduit or of the raceway is 2,938 millimeters squared. So what we're doing here is we're actually sort of creating the table 9s. Table 9G is what we've been using typically. So this is already pre-calculated in the table 9G for us. So what we're doing is creating that, or we're solving for that part of the calculation. So here the surface raceway must be to at least 2,938 millimeters squared. So what we're going to do is we're going to change that into inches squared. So we're going to go to our metric units table, take the 2,938 millimeters squared times this multiplier here, and then we end up with 4.55 inches squared minimum is what that surface raceway must be in order to make the 1,175 40% fill. So like I said, it's a little bit different, but these are actual sizes of raceways. So when I created the calculation, I just went backwards really is what I did. Took this, converted it into this measurement, and then made whatever it was 40% of, took the inches squared, went backwards, found this number here, for example, the 1931, made this, so this becomes the 100% in a sense, then found the 40% of whatever this number was, and then using this number, that's what I put together for, I just chose random conductors to add up to this value or ballpark, and that's what it ended up being. So that's how the calculations were created. I started from the end and worked my way back into the calculation. And once I had this number right here, then I just chose a multitude of conductors that sort of fit that area, whatever it was going to be. So more of the same then for the underfloor raceway. What is the minimum size surface? Oh, sorry, I put surface here. That's an underfloor raceway. I apologize. 4, 9 number 8 TW75 stranded, 6 number 6 TW75 stranded, 18 number 10 TW75 solid conductors. So again, we're just playing with some numbers here in code. Okay, this is just for the sake of the exercise. So all we do here is we have stranded and we have solid. So we got 12, 9, 10, 4D, table 10A, and table 10C, because 10A deals with stranded conductors, 10C deals with the solid conductors. So we have a total area 772.41. And here, because we're underfloor raceways, we're looking at 12, 17, 14, because 12, 1700 deals with underfloor raceways, and we're just tagging off the 40% fill again. 12900, right, deals with raceways. It sets the regulation. So this is really just a take off 12910 for the sizing of for the 40% fill regulation, right? Typically we would use table 8 here for this. So that's what these are. Is 121606 is replacing table 8, 40% fill, and so is 121714 here. So metric unit 2.99. So we just sort of go through more of the same. Table 10A, the number 8s, the number 6s. So we have to apply table 10C here for the number 10s. Add them all up. Gives us 722. This number can only be 40% of the total, or of the total area. So we just take that divided by 0.4. Gives us, that's what the minimum size of our underfloor raceway must be, the internal area. So we take our metric units, times it by our, or in the metric units, we have 0.00155 as our multiplier. And we end up with 2.99 inches squared minimum for the internal area of the raceway. And that's about it for that. So when we look at underfloor raceway again here, and we look at our bond, we'll stick a bare bond in here. So what is the minimum size underfloor raceway? So we have 8 number 1 TW75s and 1 number 6 bare. All conductors are stranded copper. I have to blank this out here, but 12, 9, 10, 4D, table 10A, and D5. It makes the reference. So D5 is where we're finding our stranded conductors. So right here, table D5, that's where this right here. And we're using the standard column. The first column is nominal. Here I'm just using standard. The standard column is just 1 over. So out of table D5, so we just add them all up here. I'm just coming over and you can see sort of the breakdown here. 12, 9, 10, 4D, table 10A gives us our number 1 aughts. Add them up, there was 8. And then table D5 in the standard column, the number 6 is good for 17.5. There's only 1. We add them up, and again, this represents 40%. So 12, 17, 14, because we're in underfloor raceways, 40% fill. Again, it's just replicating table 8. So we take that, divided by 0.4, gives us our area here, 2921.75 millimeters squared, which represents the total internal area of the raceway itself. And then we take our metric units, apply our multiplier, and we find that 4.52 inches squared is the minimum internal area required for this underfloor raceway. And that's about it. This is not too big of a deal. Just remember that we're going to be applying for the number 6 bare, the table D5, and the rules for 40% fill they're specific to the raceways themselves. So 121606 for the surface raceway, 121700 for the underfloor raceway, and again whatever code applies to whatever raceways are being calculated. And that is it for other raceways.